In each of the 4 elevators in the tower of the physics building is mounted a spring scale with a 0.750 kilogram mass hanging from it. As preparation for the 4th practical session, you were advised to take a ride on the elevator and observe the reading on the spring scale. Assume that when the elevator was stationary, you observed the reading on the spring scale to be 7.35 newtons. You then pressed the B button to go down to the basement, and just before reaching the basement, as the elevator was slowing down, you observed the reading on the spring scale to be 8.35 newtons. What was the acceleration of the elevator at the moment you made this second observation? A, 11.1 meters per second squared down, B, 1.33 meters per second squared down, C, 1.33 meters per second squared up, D, 11.1 meters per second squared up, or E, something is wrong with the data. The reading on the spring scale should have been less than or equal to 7.35 newtons.
So if you draw a diagram of slowing down, here's your velocity v down and your acceleration is upwards, okay? And because when velocity and acceleration are in opposite directions, that's the slowing down. Now, the free body diagram for the mass, the 0.75 kilogram mass, looks like this. We've got gravity pulling it down, and we've got the spring, F spring, pulling it up. So Newton's second law is that the acceleration is equal to the net force divided by the mass. And so in this case, that's going to be the spring force minus mg divided by the mass. So we can see that if F spring was equal to mg, then there'd be 0 acceleration. If F spring was like twice mg, then the acceleration would be g, so 9.8 upwards. In this case, F spring is a little bit more than mg, and so it's got to be a lot less than g, but a little bit greater than 0. So if you look over here, the only one of these accelerations which makes any sense is it has to be accelerating upwards. It's got to be one of these two. This one's too high because the spring force would have to be more than double the mg in order to have acceleration greater than g. So the only thing that makes sense here is C. A little bit greater than 0, but quite a bit less than 9.8. And just to check, to work this out numerically, acceleration is equal to 8.35 minus 7.35 divided by 0.75, which equals 1.33. So that makes sense.